Today's notes will include information on the coordinate plane. And just kind of for some background information, this whole idea of the coordinate plane was engineered or developed by René Descartes. I hope I'm saying his French name correct. And the Cartesian coordinates, you don't have this is just for your viewing pleasure, are the foundation for analytic geometry. So you guys, most of you will be taking geometry in a couple of years. We're just touching on the coordinate plane today and throughout the remainder of this year. And it provides enlightening geometric interpretations for many other branches of mathematics, such as linear algebra. You'll do a lot of that next year when you're going to graph linear equations, complex analysis and differential geometry, and multivariate calculus. And then there's just some other information that we don't necessarily need to talk about right now, but we always want to know, and we always are interested in the question, when am I going to use coordinate plane in real life? And that's a good question. Well, anytime we are dealing with maps or geography, and we do that a lot, right now in the news there's stuff going on with Russia and Syria, and starting in June we'll kind of hit that hurricane season, and they want to plot the coordinates using longitude and latitude. Where is, and speaking with hurricanes, where is the hurricane? Where is it going? How can we track it? How can we hypothesize as to which direction and where it will go and where it will land? That is coordinate plane. If ever you're traveling, you have a GPS system. They're using longitude and latitude to plot your location and to get you to your destination wherever you are going to go. The satellites that they are tapping into can plot your location using the idea of the coordinate plane, and that's this X and Y coordinates that we use that we'll talk about today to help get you to where you're going if you're traveling. So weather, here's a picture of a hurricane. We use it quite often in real life. So, kind of still for your viewing pleasure, if you close the doors, you see quadrant 1 here, quadrant 2 here, quadrant 3 down here at the bottom left, and quadrant 4. Well, the prefix QUAD means what? Who can tell us what it means? Yes, ma'am. 4 quarters in a year, 4 quarters in a dollar, 4 sides in a quadrilateral. Well, the perpendicular lines that intersect each other, and we're actually going to give those lines names. We're going to call them axes, the x-axis and the y-axis. But it divides the coordinate plane into 4 equal pieces, hence the prefix quad. The reason we have to start here is because if this is 0, and this is kind of again for your viewing pleasure, but if 0 is here, think of integers in the number line. All these values that travel to the right are going to be positive, and if I go up, travel along this axis starting at 0, think of a thermometer. As I move up, these are also going to be positive. Therefore, any point that lands in this space is going to have coordinates that are both positive. That's why we have to start with quadrant 1. And then the coordinate plane travels in a counterclockwise rotation. This big C kind of reminds me that I'm traveling counterclockwise. And if you ever forget which direction that is, look at our clock. Look at the second hand. It's traveling clockwise. Counter means what? Just tell me. Opposite. So the opposite way of clockwise, which is towards the right. Okay, so it's kind of some background information. Go ahead and open up your quadrant 1, all of your doors actually, and we're going to talk about our axes. So we talked about those perpendicular lines cutting this plane into 4 equivalent sections. By the way, remind me what a line is. What's a line? Pull on previous information. Yes, sir?
Something that starts in one spot and keeps going one way.
Where does it start?
It doesn't.
It doesn't start, it doesn't end, because both ends go on forever, infinitely. So really, we're just looking at a small snapshot of this infinite plane. And we're going to use it to plot some coordinates. So we're going to start with our y-axis. And this is what I was saying, it's kind of tough to see. But it runs vertically up and down. So if you will grab your marker, label the y-axis. You don't have to draw a box, so you can. You're going to fit quite a bit of information on this, so it's good to know that going into it. And the way I remember that the y-axis runs up and down is that if I draw an uppercase Y, this part of the Y runs up and down. So that reminds me that that's the y-axis. And it runs vertically. That's a good word to know because you may have a quiz question or a homework question, which axis runs vertically. You're going to need to know what that means. And then we have the x-axis that runs horizontally. It travels left to right. And you need them both because you can't plot a point, and that's ultimately what we're going to do, with just one value. Okay, there has to be a destination left or right and a destination up or down. The two of those together will give you a point, an address, if you will, for any point you want to plot on the coordinate plane. So we've got our x-axis that runs left or right, our y-axis which runs up or down. And then we've talked about our quadrants. And we talked a little bit about quadrant 1. We said both the x value and the y value are both positive. And that's because wherever I plot a point, I'll change the color so it shows up a little more. If I plot a point here, remember all of this space is quadrant 1. Whatever this point is, and we'll actually name specific points in a bit, because this is 0, where the lines intersect is 0, I travel in the positive direction because I'm traveling right, and then I'm going to travel upward so the y value is also positive. And that's going to happen no matter what point I plot on this coordinate plane. That will always happen. And then if we move counterclockwise, where's quadrant 2? Yes, sir?
Top left.
Top left. So here's quadrant 2. Remember, we travel counterclockwise. And in order to end up in this space, x, if 0's here, x has to be negative. Think integers, -1, -2, -3, -4. In order to end up in this space, you have to first travel left and then up. So your x value will be negative, your y value is going to be positive. Quadrant 3, in order to end up in this space down here in quadrant 3, starting at 0, you have to travel left, so it's going to be negative, and then you have to travel down. It's also negative. So both values will be negative. And then quadrant 4, which is this space here, starting at 0, you're going to have to travel right, so those values are positive, but then down. So those values are negative. Does anyone see any patterns? Like if I was to ask you to compare what's going on in quadrant 1, what's going on in quadrant 2, 3, and 4, could you see some kind of connections or form some ideas about them? Yes, ma'am.
When they're graphed, they all start with x, and then if you look left to right, it's x, y, and all of them.
X, you always have to start with the x coordinate. Awesome. No matter what point you're going to plot, you always have to know how far left or right before you even consider how far up or down. Awesome. Does anyone see any other patterns? Look at the positive negative action. Uh-huh.
On the uneven ones, like quadrant 1 and quadrant 2,
Mm-hmm.
it's either going to positive or negative.
Mm-hmm.
The other ones, it's positive and negative.
So, I'm going to send a shout out to Ariel. Ariel is saying that, and don't do this. I can erase this. I don't want you to. Looks like with our diagonals, we've got double positives or double negatives, and there's one of each in quadrants 2 and 4. Can anyone add to that pattern? Uh-huh.
It's like a proportion almost.
Oh, it does. Like, I'm thinking cross, because we do cross products proportion thing. Yep. Mm-hmm. Cross reminds me of cross multiplying.
Like,
Mm-hmm.
all 4 quadrants are different.
All 4 of the quadrants are different. Yes, they are. And then opposite quadrants are opposite each other. So quadrant 1, both positive. Quadrant 3, both negative. Quadrant 2, x is negative, y is positive. Quadrant 4, x is positive, y is negative. So in our diagonals, we kind of have the opposite thing going on. Just something to observe. Okay, label your origin. Smack dab in the middle. And our coordinates for the origin, we're going to start looking at coordinates, are 0, 0. That's where it all starts. This is the beginning. It is start. It's where we put our game piece before we move left or right or up or down. And shout out to Kylie. She mentioned this, that every ordered pair has an x and a y. X is always first. It tells you how far left or right. Y is always second and tells you how far up or down. And the way I think of it is that you have to walk to the stairs, case, before you can go up or down. You have to walk left or right to the elevator before you can jump in it and go either up or down. You drive to the airport before you can go up in the plane and descend or go down and when you get to your destination. But you always start with a left or right value or distance before you can travel up or down. Bless you. You have to ride in the ski lift. Or do they just take you? Well, actually, I've never been skiing.
I have.
Have you? I know you have. You went a couple weeks ago. Yeah. Okay, so at this point, we are going to actually plot some points. And I'm going to do the first couple with you. You can follow along with page 1 inside your blue books. There's a big old coordinate plane, and we're going to plot some of those points. So to wrap up, we've got 4 quadrants. You already have this labeled. You don't have to add this. And we rotate in a counterclockwise rotation.